Hey guys, Mr. B here again, bringing you another math video. This one on the power rule, and the power rule is one of the most fundamental rules to learn in derivative calculus. So it's really straightforward, but it's so important to understand it, know when you can apply it, and know when you can't apply it. And you'll often use it within other rules, product rule, quotient rule, chain rule, and things like that. And it's great for checking if you're doing definition of derivative questions for polynomials and stuff like that. You can sometimes check with the power rule. So if you have a function, y is equal to, say, x to the n. So x to the n could be x to the 2, x to the 1/2, things like that. So the derivative of something like that is, so we'll call it y prime. And basically what happens is this n, the exponent, multiplies the coefficient that's in front of the x, so whatever that happens to be. So right now it's just 1, so 1 times n will be n. And then you subtract 1 from the exponent, so n minus 1. So there it is. There's the power rule right there. So let's do it in a few 4 or 5 examples, maybe not 4 or 5, but a couple of examples, and see how it's used. So let's start straightforward with a couple of polynomials. So let's try it with y is equal to 3x to the 4. So just a typical quartic. So let's find a derivative of it. So y prime. So we multiply the 4 times the 3. So the exponent times the coefficient. So we get 12. My cat is meowing, must be hungry. 4 times 3 is 12. And then what I'll do is then you then subtract 1 from the exponent. So 4 subtract 1, that of course is 3. So there is the derivative. Fairly straightforward. Let's try another one really quick, very similar to that one, just in case you missed that guy. Let's call it negative 5x to the 2. So the derivative of this guy, so negative 5 times 2, the coefficient times the exponent, negative 10, excuse me, x, and then subtract 1 off. So 2 subtract 1, of course, is just 1. So there it is, negative 10x. So what you should notice is that when you use the power rule, you drop a power. So this was to the exponent 4, now it's to 3. This was to the 2, now it's just to the 1. And a linear function would go to a constant. All right, let's try a couple difference where power rule might not be as obvious. So you sometimes get something that might look like this, 1 over x to the 3. So when you have something like that, you could use some other derivative rules. You could use chain rule, could even use quotient rule, but you can also use power rule. And by far the easiest way, if you can do any simplifications at first to make your life easier, to use power rule, definitely do it. So one way we can write this to make it look more like something that we just dealt with would be to change the exponent. So since it's on 1 over x to the 3, we can write this as x to the negative 3. And that makes life a lot easier if we can do that. So then we can just take the derivative like normal. So what I have is y is equal to x to the negative 3. Let me get rid of that on and on. Here we go. So now, my y prime, I'm going to end up with negative 3 comes down in front, multiplies the 1, it's just 1, so it's negative 3. And then I'm going to subtract 1 off. So negative 3 subtract 1 is x to the negative 4. And then if you want to rewrite that, if you don't want to have a negative exponent, looks like that. Negative 3 over x to the 4. So that's a great way of avoiding some of the other more complicated derivative rules and just rearranging and simplifying in order to use power rule. Another example would be something like this. Well, before I do this example, let me just do this one real quick. So I have a video on square root of x, so you might want to check out if you're not sure. So I'm just going to do this real quick. Again, we could use the power rule for something like this because we can think of it as x to the 1/2. So if we do that, y is equal to x to the 1/2, we can just use power rule again. So y is equal to 1/2 exponent comes down, multiplies the coefficient, so 1 times 1/2 is 1/2, and then x, and then we take away 1 from 1/2, and you end up with -1 over 2. So there you go. Now the next thing we can do is one that has a root involved as well. So, I mean, that's sort of the only way you can do that is with the power rule. But we have something like this, you have options. So y is equal to x times root x. So something like this, you could use the product rule, say, where your first function is x, your f is x, and then your g is root x. But you could also, if you simplify it a little bit, you could also use the power rule, which makes life so much easier. If you rearrange this, you can think of it as x to the 1 times x to the 1/2. And then remember your rule for multiplying powers at the same base, you add the exponents. So you end up with x, 1 plus 1/2 is 3 over 2. So now you have something similar, and that's why I did the root x example, something similar to that, where you have a fractional exponent where we can use the power rule. So we're just going to, instead of differentiating this thing, we differentiate this guy. So we end up with y prime, coefficient becomes 3 over 2, root 1 times 3 over 2 is just 3 over 2, x, and then 3 over 2 subtract 1 is 1/2. And there you go. So we end up with 3 over 2 root x. So that's a great example of where the power rule, simplifying, makes life a lot easier. Now I'll do one more example. So I did this one in class a few weeks ago, and I don't think I was absent at the time, and I had a substitute, and the students were trying to figure it out, and they made life so complicated on themselves. So again, this is one where you could use the quotient rule, but if we just make one simple simplification, it's an easy question. So this is essentially distribution, right? So you're distributing the x in the bottom to each one of these. So if you don't know that, you should. But when you're dividing by a number, it's really similar to multiplying everything by a number. You have to go to each one. So it's like x to the 4 divided by x minus x to the 3 divided by x. So it has to go to both. And then that reduces to x to the 3 minus x to the 2. Now when we're differentiating something like this, we just have to use the product rule, power rule, sorry, on each one of these guys. So we just have to do it twice for each one. So we have y prime, and then this guy is x3x squared minus, and then 2x, and that becomes a derivative of that guy. So it really helps to simplify first if you can at all. I hope this helps, guys, and remember, you gotta do examples to get good at this stuff. Alright, good luck. See you in class.